Please subscribe, and you can download this code from description below. Calling a thread out of scope in Python can lead to unexpected behavior and potential issues in your code. It's essential to understand the scope of a thread and how to properly manage it to ensure the correct execution of your multi-threaded programs. In this tutorial, we'll explore the basics of threading in Python and discuss the implications of calling a thread out of scope. Threads are a way to execute multiple threads of execution concurrently within a single process. Python provides a built-in threading module for creating and managing threads. Each thread runs independently, sharing the same resources but having its own separate execution path. In the example above, we define a simple thread function, thread_function, that prints some messages. We create a thread, start it, and then wait for it to finish using the join method. Calling a thread out of scope refers to attempting to manipulate or interact with a thread outside the context in which it was created. This can lead to unpredictable behavior and potential issues such as data corruption or crashes. Let's consider an example. In this example, we're attempting to call my_thread.join immediately after starting the thread. This is problematic because join is a blocking call that waits for the thread to finish. If we call it immediately after starting the thread, the main thread will be blocked, and the purpose of multithreading, concurrent execution, is defeated. To avoid issues related to calling a thread out of scope, follow these best practices. Call join when needed, only call the join method when you actually need to wait for the thread to finish. Placing it at the end of your script or where thread completion is essential is a good practice. Avoid excessive thread manipulation, minimize direct interaction with threads outside their intended scope. Threads should be self-contained and operate independently. Use thread-safe constructs. When sharing data between threads, use thread-safe constructs such as locks, threading.lock, to prevent data corruption due to concurrent access. Understand the life cycle. Be familiar with the life cycle of threads and ensure that you are not attempting to manipulate a thread before it has started or after it has finished. By adhering to these best practices, you can minimize the chances of encountering issues when working with threads in Python. Always consider the intended scope and life cycle of your threads to ensure the correct and reliable execution of your multi-threaded programs. ChatGPT